All right, we're integrating the natural log function now. Yay! Okay, so think about this. If the derivative of the natural log function is 1 over x, what's the integral of 1 over x? It's the natural log function. Yeah, that easy, right? But there's this little twist, and you might see it right here. You see these absolute values? Okay, these absolute values are because we have to protect the domain, okay? Because we can put any number in here for x, right? I could put a negative number or whatever I want in there. But I absolutely cannot put a negative number into the natural log function. So when we integrate 1 over x, it's the natural log of the absolute value of whatever x was, okay? Because I can't put in a negative number for x. So it's just that little extra thing. It's just one more thing to remember, like plus c or whatever, that when we integrate and get the natural log, we just have absolute value. Now remember, this is one of our derivative rules, and you may not have memorized it, and that's okay, but just remember that if you see, if we take the derivative of the natural log of some function, then it's the derivative of the function over the function, okay? And so if we integrate, it's going to go backwards. Now, we're not going to use that rule a lot because I think that we could just use U-Substitution, which I understand seems like a little bit more work, but truly it's just not one more rule or trick you have to memorize. Then we can just use U-Substitution every time for anything when we have these more than one function that we're trying to integrate. So just remember we have to have those absolute values to protect the domain. So my first question for you is, and this has been asked in class before, actually it's been asked in class a couple times, and I said, don't you worry, we are going to get there. Well, here we are. When we have the derivative, or when we have the integral of something like x to the negative 1, and we've talked about this, what happens if we try to use the power rule for integration for this? What happens? Well, we add 1, x negative 1 plus 1, that becomes x to the 0. And that's not right. Like, we know that can't be right. And so that's why, and then, oh, guess what we have to do? We have to divide by 0. Oh, that's a big problem, right? That's not possible. So we can't integrate this with regular old power rules. And when you try to integrate this with power rules, you'll hit your head against the wall and then be like, oh, yes, natural log, okay? So anytime you see x to the negative 1 or something over x, just remember this is the natural log. It's the inverse of deriving the natural log. So let's try to integrate this. Okay, so this, remember, is the same as negative 3 times the integral of 1 over x dx. So I just did a little algebra there. And then what is the derivative, or what is the integral of 1 over x dx? Well, it's ln of absolute value of x plus c. So that's it. That's all. Easy, right? Okay. Monkey wrench. There's slightly harder ones, like this one. Okay. So once you get the hang of that, let's do this one. Okay, this is where we see that there's a function and its derivative. So if you remember that little, the rule from above, then you recognize that here's the function and its derivative. So this is probably just going to be ln of this function. Okay, but we're going to do it with U-Substitution just so that we can see that you don't have to remember another rule. Okay, so we're going to say let u equal p squared plus 1. So that means du equals 2p dp, and therefore dp equals du over 2p, because I just did some algebra to get dp by itself, right? So everywhere that there's p squared plus 1, I'm going to switch it out with a u. Everywhere there's a dp, I'm going to switch it out with du over 2p. Okay, so my new function, I have p over u, and then I'm going to switch out that dp for du over 2p. All right, and then I'm going to notice that I have a p on top and a p on bottom, so I can just go ahead and get rid of those. And then in the end, I'm going to have the integral of 1 over u du over 2. And that's really 1/2, right? So I can rewrite this as 1/2 times the integral of 1 over u du. Okay, well, I know how to integrate that, don't I? That's 1/2 ln absolute value of u plus c. Okay, And then I can undo my u substitution by getting this back in terms of p. So it's 1/2. I'm going to do cursive L so you can tell that's not a 1. ln of u, and u was p squared. There it is, p squared plus 1 plus c. So there you go. That's it. Okay, let's take a look at this one. So again, I see a function and I see something that's probably a derivative because I see a t cubed and I see a t squared, which makes me think, ooh, well, the derivative of t cubed is t squared, so the u is probably going to be the t cubed, and then my du is going to be the t squared. Okay, so let's see. So I'm going to make this u. So let u equal t cubed minus t squared. Therefore, du equals 3t squared. Let's see if it's going to work. T squared minus 2t dt. Okay, and then dt equals du over 3t squared minus 2t. Okay, so everywhere there's a dt, I'm going to put that. Everywhere there's a t cubed minus t squared, I'm going to put the u. So I've got now the integral of 9t squared minus 6t over u du 3t squared minus 2t. And I'm like, what? But that doesn't quite work. All right, well, let's rewrite that top part of the integral to look like 3t squared minus 2t. I'm just going to pull a 3 out, and I end up with 3t squared minus 2t on the top, and I have my u still on the bottom, and then I have du over 3t squared minus 2t. Those cancel out now, and I end up with the integral of 3 over u du, which is the same as 3 times the integral of 1 over u du, okay? And the integral of 1 over u is really easy. Once we get it to that, it's super easy. So we have 3 times ln of absolute value of u plus c. And then we just got to put it back in terms of t because we did a u substitution. So we're going to do 3 ln absolute value of t cubed minus t squared plus c. And there we go. You're done. Okay, so those are the easy ones. And every so often you're going to have ones that the numerator and the denominator are either equal, the degrees are equal, or that the degree of the numerator is greater than the degree of the denominator. Okay, because in this case it was really easy because we have the function on bottom and its derivative on top, right? But if we have something that where the function is not on bottom, the function is on top, we need to do something different. We need to use long division to split this fraction up so that it is, so that the degree of the bottom is bigger than the degree of the top. So what you might remember from long division, and you might not, that's okay. I have other ways of setting up long division. If this really just is hard for you, there's other ways I could show you. But we set up long division like this, okay? And then we divide. X squared goes into x squared one time, and then we multiply 1 times x squared is x squared. 1 times 2 is 2. And then we subtract. So we get 0 plus 4x, minus 4x, because it's negative 4x minus 0, minus 4x, I'm thinking ahead, plus 0. So our remainder is negative 4x, so we write our remainder, remember, minus 4x over x squared plus 2. So we just write it like that. So what I'm telling you right now is this right here is equal to that. It's the same thing, I just did a little bit of creative algebraic manipulation. So I can rewrite my integral like that. Okay, so now it's the integral of 1 minus 4x over x squared plus 2 dx. And now I'm okay because the denominator, or the degree of my denominator is bigger than the degree of my numerator. Okay, so we know from integration rules that I can split this. So that's 1 minus the integral 1 dx. Excuse me, I should write keep my notation good. Okay, minus the integral of 4x over x squared plus 2 dx. Okay, then I can integrate. And first, I'm going to integrate that. That's easy, right? That's just x, okay, plus c, but we're going to tack on a plus c anyway. Minus, and then here's the one that's a little more challenging to integrate. We're like, ooh, how do I integrate that? Well, we're going to do a U-Substitution again. So I'm just trying to organize my, I'm not great at keeping my notes organized for you guys, so I'm working on that. Okay, so if u equals x squared plus 2, then du equals 2x dx, and dx equals du over 2x. Okay, so we're there. And then we can just go ahead and do our substitution. So everywhere that we had the x squared plus 2, we're just going to put a u. So we're going to have 4x over u du over 2x. And we notice that those cancel out and we're left with 2 on top. So our new integral is 2 times the integral of 1 over u du. Bring that up above my head so you can see it. Okay. And we know how to integrate that because the integral of 1 over u is ln of absolute value of u. So this is 2 ln absolute value of u plus c. Okay. Then we can turn it back in terms of x. So 2 ln absolute value of x squared plus 2 plus c. And so we can bring that back up here, right? So we integrated the purple one. Now we integrated the green one. So we have 2 ln absolute value x squared plus 2 plus c. And that's it. We're done. That's your whole integral. It's not terrible.